Hi and welcome to this video where we are going to talk about how we can use AppWrite in conjunction with CloudConvert. So these two technologies, I'm going to assume that you know already what these are, and that is why you want to learn how we can make them work together. But if you still don't know, then you can come to the website of AppWrite and you can read it, what all features it provides, what exactly is this technology. And also for CloudConvert, you can go to their website and check out what all they have to offer. So starting with AppWrite, we are going to look at a task where we are going to use AppWrite's storage. What primarily CloudConvert offers us is that we can give it a file, we can apply several operations on it, and then finally it will give us a converted file. Now that kind of conversion can be anything. We can convert a PNG to a JPG, we can send a video or an audio or any other type of file and get it optimized. Also, we can give it multiple files and it will generate a zip from them which we can download. And there are several other functionalities which you can find out on the website in their API documentation. Now this documentation is really great if you want to learn in depth about what all features there are in CloudConvert. Apart from that, they also offer many SDKs that will make your life easier. We will see how we can use Node.js SDK, and also if your preferred language or your technology is not present in one of them, then also how you can make this work. I'll be covering that. So if we come to the dashboard of CloudConvert, you will see that there is a 25-minute conversion limit by default, which means for 25 minutes every 24 hours you can use CloudConvert's processing power for free, and then it will stop responding to your requests. Now to extend that 25 minutes to infinity, you can come to the sandbox here. Now the rule of sandbox is that you should first whitelist the hashes of files that you're going to be using for testing your application. This is to prevent users from deploying this application using just the sandbox API and using that in production. So first you have to specify, let's say my file is coding.png, it can be any name that you want, and the MD5 hash of the file. To get that hash, you can say MD5 sum, the name of your file, and it will give you here the hash of the file, which you can paste over here. Now all the files that have been listed here, CloudConvert will allow operations to be performed on them. For other files, it will simply reject those requests that are made on Sandbox API. If you use the standard one, then there is no need to whitelist any files, but it will take up your conversion minutes. Now if you want to see how we can use this CloudConvert API to actually perform our tasks, then you have to come here to the API documentation, and inside that you should first go to a job builder. Now here we can see the basic layout of what our request should look like. You can read this instruction also, but I'm going to do it here. Now first, there are three broad ways in which you can perform operations on file. Firstly, importing the file. Now there are many options here for import, for tasks, and for export, and you can find more information about all of them inside this sidebar. Here we have URL, upload, base64, and all of those options available here. For task also we have convert files, optimize file, and other things. For export, here are all the options. Now what are these things? Import, task, and export. Import means you want to get a file from somewhere. Now these are the options for it. We are going to be using the upload option. We can name this task whatever you want to. Let's say upload file. Now as you can see that here inside a tasks object, another object has been added, which is upload file, and the operation is import/upload. Now once this file is uploaded, we want to convert this file, let's say, into a JPG file. we can name this task as convert file. Input is going to be the output of the previous task, which was upload file. In the output format, we can say JPG. You can see all the other options also, but right now they're not relevant. Now once we are done converting the file, we also want to download it. So let's say we want to export it in the form of a URL. Now this URL, let's call it export file, and the input to this is the output of convert file. And when you look here, this entire thing is our job, and this job has a tasks object, and this tasks object has all of our various tasks that we just created here, and they are performed in order. So first this upload file will be started, and once that is completed, then this task will be run, and it goes like that for all the tasks. Now if I run a sample here, I'll browse and choose a file, and this is a PNG file. Now if I execute it, you will see all the tasks running here. First the upload file is finished, then it will convert the file, and once it's finished, it will export the file in the form of a URL. You can see that the upload file here is coding.png and the export file here is coding.jpg. If you look at the bottom of the screen, you can see that this is storage.cloudconvert.com, and this is the unique URL from where we can download our file. If I click this, it will start the download, and here you can see that this is the same file which is now in JPG format. Now since we might be using Node.js SDK, we do not have to worry about many details. Details like what is the response that we are getting, what is the schema of this response, what is the flow of CloudConvert. We do not have to worry about all that. We simply have to click here on Node.js and it gives us the code. Now we will look more into details of this code later on, but right now we just have to see that this is the only code that we have to write, and all the operations, that is uploading, converting and exporting, will be performed for us. Now let's talk about what are cloud functions in AppWrite. If you go into your AppWrite project, inside this functions tab, you will see that these are cloud functions. Now these functions are basically independent pieces of code that can work in conjunction with your AppWrite. So let's say we want to add a new function, name it test function, and here are the various runtimes available for you to choose. If you want to add another runtime, then you can do that by going into your AppWrite folder, and here you can see there is a .env file. If you print out the contents of this file, then here you will find app functions runtimes is equal to all of these runtimes, and these are exactly the ones that are available to us. If you want to add more to them, you simply have to add comma and the name of the runtime you want to add. So let's view one of the functions that I've already created, and this has been created in a Dino runtime. Here I can execute this function by clicking execute now, and here I can provide JSON that will be supplied as parameter to my function. Here these are tags, and tags are nothing but your pieces of code that you want to execute. Here are all the stats that you can view for your application. Here are the logs, so you can see when was this application run, what was its status, trigger was whether it was HTTP or some AppWrite event that triggered it, how much time it took, what was its output, and if there were any errors, they will be present over here. Inside the settings, you can rename this folder, and there are a couple of other settings, but we'll look at the variables here. And what are variables? Variables, they're basically some secrets that your application uses, that your code uses, and since we do not want to write those secrets inside our code, we extract them from our code and keep it in some separate place, and that place is basically variables. When you upload your function to cloud, to this AppWrite instance, that is when these variables come into play. Now it's time to look at some code. This code you can find out in demos for functions repository of Apprite. Now let's look at what this code is doing. Firstly, the purpose of this code is to take a file from Apprite storage. I'll just show you the file here. This is a coding.png file. And we want to take this file from Apprite storage, upload it to CloudConvert, convert it into a JPG file, and then finally download it and place it back in our storage as coding.jpg. Now firstly, we have to install Node Apprite, which is SDK provided by Apprite for Node.js. So we are importing it here, and then after installing CloudConvert's SDK for Node.js, we are importing it here. Now you can read about what streams are, but basically Node.js doesn't give us any option to use blobs. Blobs are binary long objects which basically help you in storing your file data into a variable that can be used later on. So that is what Node.js is missing, and that is why we use a readable stream, and this stream is basically reading data from your file or from a buffer, and it will keep on reading that data till the end of the file. Now Axios, we are just using it to make fetch, get and post requests to CloudConvert. Then we are requiring .env, which is done so that those secrets that we just saw in the variables here, these variables, they're exactly what go into our .env file. Now this is how we are going to convert to Apprite and to the storage of Apprite. Now this is how we create a new client. We call this and create a new object from it. Then for that object, we want to access the storage. So that is how we create another object for it. And this is connecting to CloudConvert. We just create a new object and pass in the our API key here. If you want to use the sandbox, then you just have to pass a second parameter, true, like this. Now this is how we can connect Apprite to our code. This is client, which we just created here. First we set the API endpoint, and that endpoint you can find inside your if you go to your project, inside the settings, here you will find your API endpoint. Now you have to set the project, and this project is basically the project ID that you will find over here. And set key, this is the API key which you can find inside your this home page under API keys. Here is the API key that I created. You can show secret, and that will be your variable for this one. Now as I said that inside a function you can send parameters to your Apprite function from here. Now to get those get that JSON and to be able to use it with JavaScript, you have to make it work like this. Firstly, we get it from Apprite function data. This is by default injected into our application, just like other .env. The way we access other .env variables, we have to do the same here. And then we use json.parse because that is in the form of JSON, and we need to convert it into an object so that we can extract properties from it. So that's why we are doing json.parse and getting that parameter here. And after this, we can access those parameters. We have connected to Apprite, we have connected to CloudConvert, and now our next step is to finally create a job. So our next task is to create these jobs. And since we are doing the exact task that we did here, I just copy pasted the code. This is exactly the kind of JSON that was given to us here. Now, out of all of these tasks, which one do I want to upload my file to? It is the task whose name is upload file. So that's what we do here. From the job here, dot tasks here, we want to filter. And the filter that we apply is that the task name should be equal to upload file. And then we get the first element from the filtered array. and that first element is nothing but this task here. File details. Now this file details, this is needed because when we are trying to upload to CloudConvert, we also need to supply the name of the file. So here you can see here that when I'm going to upload to CloudConvert, I'm supplying the file name here, and that is why we have to fetch the file metadata from our AppWrite storage, and this getFile function does exactly that. We have to supply the ID of the file which we are getting from the parameters that we are going to supply while executing the function. Now we supply that ID to the storage, and this getFile function will give us the metadata which includes the name of the file. Now since this Node.js doesn't give us any blobs, we have to create a buffer. And how do we create that buffer? We get file download from it. This function basically gives us the data of the file. Like this function gave us the metadata of the file, and this is going to give us the contents of that file. Again, we supply the ID and we create a buffer from it. You can read about buffer, what exactly they are and how they work, but that is not relevant here. Now from that buffer we have to create a stream, a readable stream, and that stream is what is going to help us to upload the file. So that is what we supply here in the upload task. We are saying cloudconvert.tasks.upload the upload task here, which means for this first task we want to upload the file, then the input file, which is the readable stream that we just created, and the file name. Now once we are done with this, we have to wait for all this to finish. Once we have uploaded the file and CloudConvert has processed it and converted into a JPG file, then we have to get this URL from this task, and then we have to download the file. But before getting that URL and making a request for downloading, we have to wait for this job to finish, and that's what we are doing here. We say cloudconvert.jobs.wait, we supply the job ID, and that job ID will be given to us when we create this job over here. When we create this job, it will give us a job ID, and that we are going to wait for that job ID to finish. Now once that finishes, it will again give us a result which we are assigning to this variable here. Now once we have received the response, then we have to call job.tasks.filter, and this time we want the final tasks output because we want the URL from where we can download our file. So that is what we are doing. Inside the tasks of that job that we created, we want to filter the task whose operation is to export a URL, and also we want to confirm that the task has been finished. That is why we are saying task.status is finished, and we get the first element from it, which is our export task. Now if you look at the JSON of this export task, then you will be able to see that there is information about the file inside a result object. So we get the first file from it, and since there is only one file, it will give us the JPG file that is what we want. Now what we want to do is download that file. To download that file, we supply the file.url, and this URL we are getting from here. The file object that we just extracted, it will have this URL property, and we are receiving it in the form of array buffer. You can read more about this array buffer, how it works. Now to create a file inside our AppWrite storage, we have to give a read stream to it. And how we can create a read stream, that is what we just discussed here. We first create a buffer, and from that buffer we create a read stream, and that is what we are going to do here. We firstly create a buffer from the response that we get here in the form of UTF-8. This is important to supply, otherwise your file will not be in the way that you expect it to be. And then when we create a readable stream from it, we also have to supply a name, because this is the way that AppWrite works behind the scenes. When we are calling create file, inside the read stream, it also expects a name property. Once we have added the name to our stream, then we can create a file, supply that stream to it, and wait for the converted file. Now, this converted file will again be the file metadata that we got from get file here. And then if we want the ID of the newly created file, we can return it through this. So this was all about how we can leverage the SDKs provided to us to create file and perform all those operations that I just showed. Now what if you do not have any SDK? For example, while working on a task in Dino, which is basically, it can be called as a modification to Node.js, CloudConvert did not provide any SDK for that, and because of that I had to learn how the CloudConvert is working, what is the flow of this application, how are these tasks being performed, and how are the files being uploaded. Because right now we are just calling the function like upload, wait, all those functions, how are they working? I went ahead and read the code of the SDK, and that's what we are going to cover in the next section, how we can work with CloudConvert without actually using any of those SDKs. If you want to see the code of SDK of Node.js provided by CloudConvert, you can simply Google it and you will find a repository, and by reading that code is how I understood how it is working. So when we create a task and we send it to CloudConvert, it will basically return us a response which is in this format. Now this response also provides us with some crucial data that is needed for uploading the file. So there are actually two requests being made to CloudConvert. The first request is to basically register these tasks and the job that we created with CloudConvert. After registering them and getting this data back, we have to make a second request, which will be to upload the file for the upload task. If you look at the first task, this is the newly created object which CloudConvert would have made behind the scenes for us, and we can see that it is waiting for file upload. Now it has given us inside this result a form with this URL and these parameters. Now this is the URL where a request should go, the second request should go, and these are the parameters that must be supplied inside the header of the upload task, so that Apprite knows that it is the CloudConvert knows that it is coming from us and not from a malicious user. All of this data is necessary, and hence we must add it to our form data when we are uploading it. So this is a different file that I'm working on. Here I'm working in Dino, so I am importing the SDK for that, for Apprite, and then the way .env is present in Node.js, I'm doing a similar thing here. You do not have to worry about this because right now our focus is on CloudConvert. So I'll skip all this and move on to these functions here. We'll talk about those functions in detail, but let's first see what is the flow that we are dealing with. Here I've created a job that is identical to the one that we previously did. Here it's a little bit different. Here I'm trying to optimize a file. By optimizing a file, it basically means we upload a file of, let's say, X MBs, and CloudConvert will optimize that file, which is, it will reduce the size from X to some X minus something, and that is what optimizing is. So that is the task that we are trying to do here. There is not much change in other things. Now firstly, as I said, the first request is to post those jobs to CloudConvert so that he can register us and return us a response in this format. This is the endpoint where we have to make this request. The method is going to be post, and inside headers we have to authorize ourselves, and for that we are providing the CloudConvert API key, which we when we were using Node.js, we were simply providing this API key to the class, to the constructor of the class of CloudConvert, but right now we can also do this in authorization header, and the content type is going to be JSON, so that's what I specified here. And we have to convert the jobs, which is this object here, we have to convert this into JSON. And the way we do that is using json.stringify, and that is the body of our request. Now once we get a response back, we have to first parse the raw response, and that's what this function is doing here. It is basically doing json.parse, uh, which we saw earlier in the video, and that is what it returns. This function returns the JSON parsed object to this, and this function will return that object to us, and we are storing that in response. Now from that response, we are doing a similar thing. We are filtering the task upload file. Then inside the response, I filtered through the JSON and find that the job ID can be found by going into response.data.id. Now why this ID is needed, we'll see that later on. Now to upload files, we need a special type of we can say special type of form data, and that form data is basically written as multipart. Now this multipart is the kind of form that that is submitted, which contains a file as well as some other details, which we'll look at just in a while. So to create a form data, we have to first apply an upload task. Now this is by default available in JavaScript, a form data class. So we create an object, and the parameters that are listed here, we add all those parameters into our form data. So for all the parameters in upload task, this is again I read through the JSON and found what where can we find all these parameters in it. So for all those parameters, we take them and append them into our form data. Now once we have done that, we do a similar thing like getting the file metadata, getting the file's contents, and this time, since we are not working in Node.js, we can use blobs, and that's why I'm using, instead of a readable string, a blob here. And that blob I will supply here. We are first appending, this is hard coded, this is file, and this is the way it is expected to be supplied to CloudConvert. This is going to be another object basically, where file is the key and the value is going to be this blob that we are supplying, and from the file metadata we are giving it the name of the file. So when we return this form data, we store that form data here, and then we make our second request, which is to upload the file. So we supply upload task and form data to this function. Now what this function does is it basically calls the URL that was supplied to us, as you saw here, that result.form.url. we are making a request to that. Method is post, and the data is the form data that we just created. Now we just wait for it. There is nothing that we want to the response is not relevant to us, so we are not storing it anywhere. Now as in the Node.js SDK, you saw that we were waiting for the job to finish by simply calling cloudconvert.jobs.wait, but since now we do not have that option, we have to create another request, and that request is meant to go to this API endpoint. Here we have to say jobs, we have to specify the job ID and then wait. So when this job is finished, this promise will resolve. It will give us the response, and that response again we will parse it in the form of a JavaScript object, because it was JSON, so we have to parse it as JavaScript object, and that is the response that we return. So we are getting the result, and again, as we saw in the SDK part, we have to filter the export task, which in this case is named as optimized file URL. We get that URL, and this is similar to what we did in the last using Node.js. We get the URL of the file. We also get the file name, so that we know with what name we should be storing it into AppWrite. Then finally, we download the optimized file. We have supplied it the URL, so we fetch that URL directly, we get the blob, and we return it. When this is returned, it is stored in this, and now storage.createFile. So this createFile function expects either a buffer or a file object as its input. So we are creating a file object so that we can also specify the file name, because in case of blobs you cannot specify file name. So that's it. That is why we create a new object of file, provide this blob as an array of this. This is the way it has to work. You can read more about it in the documentation. And we specify the file name here, so it finally gives us the file which we then store into our storage here. And that is how the entire flow works. So even if you do not have any SDK available, you can still work with CloudConvert by using this kind of flow and basically doing all the work that SDK did for you by yourself, by creating those requests on the relevant endpoints and also specifying the right headers and also the right parameters for form data. I'll just run through an example so you can see how this is working. I will take this PNG file, I will get its ID from here, and then inside my function I will execute it providing the ID of this file in JSON format. And then I will click on execute now. This will start my function. As you can see here, it is waiting. And while it is waiting, I will just add another detail. Inside your AppWrite API endpoint, you should not be putting localhost /v1 here. Instead of using that, you have to use your local IP address. And how you can get that address is by going into your terminal and typing hostname -I. Now this is the local IP address, and that is what you should be putting in here for it to work. Now if we go back to our storage, you will see that another file called coding.png has been created here, and since this was optimized file, you can see that the actual size was 409 KB and it has been optimized to 115 KB. And inside CloudConvert, you can see that coding.png was uploaded, the file size was reduced by 71%, and finally coding.png was exported, and this URL is what we fetched from and put the file inside our storage. So that was how we can use AppWrite with CloudConvert. You can go as creative as you want with AppWrite, and there is always demos for functions repository where you can find more examples on this. And also you can join our Discord community, which is extremely supportive, so we can resolve any doubts that you might have. Thank you for watching.